Greetings guys, and welcome to another edition by iCampSA. In this edition, we're looking at grade 12 mathematics, and we're looking at the practice assignment that was released on the day 11 May 2026. If you observe carefully, in total, the assignment is 100 marks. It is for a duration of 2 hours. This is going to be part 1 of our lesson where we solve a couple of questions. Then there's also going to be part 2. So as part of our part 1 edition, let's go ahead and have a look at the questions we are required to solve. So the first question reads, in the diagram below, M is the center of the circle, RS is the tangent to the circle at point D, Y and X are points on the circumference of the circle, dy, dx, and yx are joined. We are required to prove that x angle dr, which is this, it will be equal to xyd, which is that. Now, if you observe carefully, you should be able to recognize the theorem that we are working with here. And the theorem that we are working with here is called the Tan-Chord Theorem. And what this theorem states is the angle between the tangent and the chord is equal to the angle in the alternate segment. Okay, so let's go ahead and prove this here. So what we are required to do really is to go and prove that our angle D1 equals Y. That is what we need to prove. So as part of our proving, whenever you're proving your Tan-Chord theorem, you will always draw the diameter that will cut through the center. And then because we are trying to show that this angle Y is equal to that, we are trying to show that angle Y will be D1. The line we draw, we will always draw such that it is going towards the angle we want to prove, which is angle Y. Okay, done with that. Now, what I'm going to do is to label this here. So I'm going to label this as Y1, then this is Y2, and then we are going to call this point here Z. Okay, then in the interest of making this to be easy for us, I'm going to call this D1, D2, and D3. Okay, now if you observe carefully, you should be able to see that our ZD, according to how I drew it, that becomes our diameter. And this simplifies our life because we can now figure out what angle Y is. Angle Y, which is the same as Y1 plus Y2. This should be 90 degrees, this angle. If you look carefully, the reason is going to be it is an angle in a semicircle because this is a diameter. So that is the reason. So let's quickly fix something. We already have D1 here. So let's just quickly fix this. So this is going to be D2, D3, and D4. Okay. And then what we know is that our diameter will always be perpendicular to our radius. Our diameter will always be perpendicular to our tangent, or the radius will always be perpendicular to the tangent. What does that mean? It means that if we look at D1 plus D2, that should be 90 degrees. What is the reason? We can say radius perpendicular to our tangent. So it can also, the same can be said about D3 and D4. So when you add them up, you should get 90 degrees. But our focus is really on D1. That is why we took the side that has D1. Now, we need to ask ourselves a very important question, which is which other angles are equal in this diagram? Now, if you observe carefully, you should be able to see that this angle and this angle are equal. It is because they're in the same segment, or they are subtended by the same arc. And this angle and that angle will be equal. Okay, so we'll focus on the D's because that is where we have something related to D1. So if you observe carefully, your angle D2 will be the same as your angle Y1. What is the reason? These are angles in the same segment. So with this in mind, now we can go ahead and conclude. So if you observe carefully, we had two equations, which were these. Let's copy them. We had these equations. And what we just found out now is that this angle here, y1, is equal to d2. So now if you think carefully, if y1 is equal to d2, then it tells us about something about this one, d1 and y2. So if you look carefully, we can therefore conclude that these are equal to. So we can say therefore because they are adding to the same thing. Think about it. So we can rewrite this equation. Maybe it will be easier to see as d1 plus I can put y1 equals 90 degrees because remember our d2 is the same as y1. Then we can say that y2 plus your y1 equals 90 degrees. So now if you observe carefully, it should be very easy for you to see using this equation 1 and 2 that if these are the same, y1 and y1, in order for us to add up and get the same thing, then these guys must be the same. Okay, so you can clearly see that therefore our angle d1 is equal to y2. Look at what y2 is. y2 is the angle x, y, d. So we can therefore put up what they were expecting. So they gave us this as x, angle dr, and this will be x, angle y, d. And just like that, you are done and your teacher would be happy. So I hope that this does make sense. Make sure you know your proofs. Tan-Chord Theorem, your cyclic quad proofs, all of the other proofs, make sure that you do know them. So let's go to the next question, which is still 1.2. And for this question, we are told RS is the diameter of the circle with center O. Then chord ST. Let's have a look. Where is ST? There's ST. Chord ST is produced 2W. Okay. Then we are told chord SP. Where is SP? This is SP. Chord SP is produced meets the tangent RW. So essentially at point V. Then we are given R1 to be 50 degrees. And then we are asked a couple of questions. So let's quickly put in our 50 degrees there. Then we are asked, what is the angle WRS? So let's go and figure that out. It's WRS. So if you look carefully at our diameter meeting our tangent, that should be very easy for us to figure out. So that becomes our 1.2.1. So that WRS is 90 degrees. The reason is we can say radius perpendicular to our tangent or diameter perpendicular to the tangent. It is as good as the same. So radius perpendicular to our tangent. Okay, done with that. Then they're looking for the angle W, that angle there. So how do we figure that out? Well, if you observe carefully and you remember your Tan-Chord theorem, you'll see that the 50 which we are given is an angle between a tangent and a chord. And the angle between a tangent and a chord will be equal to the angle opposite the same chord. What does that mean? This means that our angle S as a whole, that will be equal to R1, which is 50 degrees, and that is going to be our Tan-Chord theorem. So it is our Tan-Chord theorem. That is what angle S is. Now, if you think carefully, if you now have this as 50 degrees and you have that entire angle is 90 degrees, then figuring out W should be very easy, because now you're looking at the bigger triangle, which is this triangle here. So what you should be able to see is that angle W plus angle R, or let's just say plus W angle RS and then plus angle S, that should be 180 degrees. And this is sum of angles in a triangle. Okay. Then we now have our angle W plus our 90 degrees, then plus our 50 degrees equals 180 degrees. Then you can transpose and you'll see your W will be 180 minus 90 minus 50 degrees, which will end up giving us angle W very easily as 40 degrees. Okay, I hope that you do understand. Now let's go and have a look at the next question. So let's put our 40 here, 40 degrees. Now the next question requires us to find P1. So let's have a look at where is P1 here. So here's P1. That is P1 there. Now the question we need to ask ourselves is, here we're at 90. Yeah. What other angle is equal to P1? That is the question which we need to ask ourselves. So, but let me just split these here. This was 1.2.2. Now let's have a look at 1.2.3, where we're looking at P1. Now, if you observe carefully, P1 is actually equal to this angle here, that R2. So if you observe carefully, you'll see that angle P1 is the same as angle R2. What is the reason? These are angles in the same segment. So that is what we get. For anyone who doesn't see this, look carefully. This is what we have. Okay, that is what we have. Very important. But now we need to ask ourselves, what is R1? Sorry, what is R2? Finding R2 should be very easy, because we figured out that R1 plus R2, that is 90 degrees because of that our radius being perpendicular to our tangent. But we were given R1, so R1 was 50. So your 50 degrees plus R2 equals 90 degrees, which means your R2 is the same as 90 degrees minus 50 degrees, which then gives you your angle R2 to be equal to 40 degrees. Okay, but we know that P1 equals R2, so therefore the angle P1 we have found as 40 degrees. Right, done with that, let's go to the next page and see the next question. So for the next question, we are required to prove that angle V1, this angle, is equal to P angle TS. Let's have a look at which angle is that. So we have P angle TS. Now, in order for us to easily prove this angle, let's quickly put in the values that we already know. So if you remember, here we're at 40 degrees and then this entire angle, we had it as 50 degrees, if you remember, and then that was 50 degrees. We found this one to be 40 degrees, and we found this one to be 40 degrees too. Okay. So let's go ahead and see how we can find this relationship here. So what we can easily find, or what we can see, is that because of V1, we need to work with this quadrilateral. So we need to work with this quad. Okay, and if you observe carefully, we need to find P2. Angle P2 plus P1, if you observe carefully, plus angle P1, that should be 180 degrees. These are angles in a straight line. So we're trying to get the angle that is inside so that we can sum all the angles. Okay, which means that our P2 is going to be plus 40 degrees, and that should be 180 degrees. And if you solve for P2, you will see that P2 will be 140 degrees. Now we can add all the inner angles. So we can have angle W, then plus T3, and then plus P2, and then what is the third angle? And then plus V1. And this will be, remember when you sum angles of a quad, they add up to 360. Angle W, we already have, it's 40. Angle T3, we don't know, we leave it as T3. And then plus angle P2, we know that's 140 degrees. And then plus V1, we don't know, that equals 360. So 40 plus 140, that sums up to 280. Then what you will see is we'll be left with V1 plus T3 equals our 360 minus 40 degrees and then minus 140 degrees. And this, if you observe carefully, if we try to solve for V1, what we will have is on the other side, we'll be left with 180 degrees. So if we solve for V1, you will see that V1 is 180 degrees minus T3. But if you observe carefully, T3 is in a straight line. So when you say 180 degrees minus T3, that is what you get. So this portion here gives us the other angle. When you say 180 minus T3, what you end up getting is the angle T1 plus T2, of which that angle is the same angle as, if you observe carefully, P and then angle TS. So that is how we do this, okay? Of which this is the same as 180 minus T3, because these are angles in a straight line. So therefore, our angle V1, we have shown that it is equal to P angle TS. And that brings us to the end of question 1. Next, we'll look at question 2. So let's now have a look at question number 2. Okay, question 2 reads the statement, in the diagram, PQ is a tangent. If you observe carefully, it is the tangent to the circle QST at Q, such that QT is a chord of the circle and TS produced meets the tangent at P. R is a point on QT such that our PQRS is a cyclic quad in another circle. Okay, then we are told PR, QS, and RS are joined. So we are required to give the reasons for each of the statements. So we are told that Q1 equals angle T. Now, if you observe carefully, this should be a bit easy, because when you look at Q1, so Q1 is the entire angle. So if you look at Q1, you will see that it is the angle between, if you observe carefully, the tangent and the chord, and it is equal to the angle opposite the same chord or in the alternate segment. So the reason for that is these being equal, very simple. It is our Tan-Chord Theorem. Okay, done with that. Now let's go and have a look at the next one, where we're looking at, let's use green. They say Q2, which is that angle, it is equal to P2. So let's look for P2. P2 is there. Now, if you look at how Q2 and P2 are, and then you look carefully that we have a circle like that, you will see what is happening here. Let's maybe shade our circle. Now, if you observe carefully what is happening, this is what we have. So I hope you can see why Q2 and Q and P2 are equal. It is angles subtended by the same arc or angles in the same segment. Okay, so here I'm going to say this is angles in the same segment. Okay, done with that. Very important. So now with this out of the way, we can go ahead and look at the next set of questions where we're looking at 2.2. 2.2 requires us to prove that PQR is an isosceles triangle. So let's go first and look at which triangle is that. So we're looking at PQR, which is this one, PQ. So PQR. So essentially, this should be very easy to prove, because if we are trying to prove PQR, we just need to show that two of these angles are equal. So it's either we need to show one of these or two of these angles being equal. That is what we need to do. If we have two equals angles or two angles being equal in the triangle, we are done. So in order for us to prove this isosceles triangle, we are going to do two things. So we are going to focus on triangle SQT. And when you look at SQT, you should be able to see that if we take angle T plus angle Q2, that will actually be equal to angle S1, which is just the exterior angle of a triangle. Okay, so that is what S1 will be equal to. But if you observe carefully, you should be able to see that S1 is actually the same as R1, but S1 equals R1. Okay, but then remember that S1 is equal to angle T plus, if you observe carefully, angle Q2. But if you look carefully, we've shown that QT, angle T is the same as Q1, so which means our angle S, therefore, our angle S is the same as angle Q1 plus our angle Q2. Okay, that is what we have. But observe carefully now if you redraw this triangle of ours. Let's quickly draw it. Now, if you look at what has happened, we now have angle P here. Then the angle Q which we have here is a combination of Q1 plus Q2. Now, we have found that our S equals R1. And our R1, we just found now that it's the same as Q1 plus Q2. Because if you observe carefully, our S1 equals R1. So therefore, our R1 equals Q1 plus Q2. Now, if you observe carefully, you now have base angles that are equal. This angle is equal to this one. Therefore, we can conclude, therefore, that triangle PQR is an isosceles triangle. The reason is we have two equal angles. So once you have two equal angles in a triangle, that makes it to be an isosceles triangle. So let's go ahead and finalize this answer. So if you look carefully, angle T plus our angle ST is the same as angle Q, okay? So what we have is angle Q equals our R1. If you look carefully, R1 at the top there, it is the same as angle Q. So we end up having angle Q, then plus angle R2. And if you observe carefully, these will subtract, and what we will be left with will be, therefore, our R2 will be equal to our angle T, which is exactly what we wanted to show. So we can conclude now and say PR is a tangent. And then the reason which we are going to give is the converse. We are thinking in reverse now. Converse of our Tan-Chord theorem. So that is the reason that we'll give, because we are thinking in reverse. So the angles are equal, therefore we have a tangent as our PR. If we were told PR is a tangent, we would know the angle between the tangent and the chord would be equal to the angle in the alternate segment. Okay, I hope that does make sense. Let's go and have a look at the next question. So let's now have a look at question 3. Okay, so in question 3, it reads, if triangle PQR and triangle STU, if in triangle PQR and triangle STU, it is given that angle P equals angle S. So what I'm going to do is highlight. So this angle, we are told it is equal to this one, okay? And then, let's go for green. Then we are told angle Q is equal to angle T, okay? And then we are required to prove the theorem that states that PQ divided by ST is the same as PR divided by SU, okay? So essentially, if you observe carefully what this is called, this would reason as our proportionality theorem. So what we know about triangles is that once we are given angles, or in the two triangles, the two angles are equal, the third angle becomes equal. Okay, so we can go ahead now and state that our angle R is equal to our angle U. And the reason you can give, once two angles are equal, you can always say the third angle of a triangle, okay? And you will get marks. So once we have three angles that are equal, what does it mean about these triangles? What this means is that these triangles are similar. So triangle, so if you look carefully, triangle PQR will be similar to triangle PT STU. So STU. And the reason will be angle, angle, angle. Okay. We found our three angles to be equal. Now we need to prove that we can divide those sides like that in proportion. And for us to prove that, we are going to use, I'm going to use the area rule. Okay. So what I'm going to do is I'm going to divide the areas of these two triangles. So I'm going to have the area of, but let's look at the sides. So we have PQ, and PQ comes from this triangle, okay? So that means I'm going to put the triangle above at the top. So I'm going to have the area of triangle PQR divided by the area of triangle STU, okay? So what I'm going to do is two things. I'm going to use the area rule, and I'm going to look at the sides that I really want. So we need PQ, and if you observe carefully, we also need PR. So if we need PQ and PR, we are going to make this to be very easy. We need PQ and we need PR. So what this means is I'm going to use angle P as my included angle. Okay. So let's go ahead and do this. So what we are going to have is, if you think carefully, we're going to have three combination of areas here. So let's take as an example the red angle. So that is what we are focusing on for this one. So if you look at the red angle, what we are going to have is half of, if you look at that one, it's going to be PQ and then multiplied by PR and then times sine of angle P, okay? And then we are going to divide by, if you observe carefully, we'll have half of ST multiplied by SU and then sine of angle S. But remember that angle S and P are equal, okay? So what this means is that this and this, they are going to cancel. So meaning that we end up finding our answer as, let's put in an equal sign. We end up finding our answer to be PQ times PR and then divided by, if you look carefully, ST times SU. But also using another angle, we can compute the area and get something different. Okay, so let's use this one here, the purple one. So if we use the purple one, we'll have half of, if you look carefully, we'll have PR and then times, that becomes our included angle. Then you'll have your RQ and then sine of angle R. And this will be divided by half of, if we look at the same angle, you'll have SU and then times, if you look carefully, you'll have UT and then sine of angle U. And this will cancel out. So if you look carefully, this here will cancel out and also the halves will cancel out. That leaves us with PR times RQ. Sorry, it is PR. Let me think. PR times RQ, okay? And then divided by SU times UT. Okay, then we can calculate again using another angle. Now we are going to go and use the green one. So if you use the green angle, you will see that what you end up having is half of, from the green angle, we have ST times UT. Sorry, now I'm looking at the bottom one first. Let's look at the top one. We'll have PQ and then times QR and then sine of angle Q. And this will be divided by half of ST, if you observe carefully, times our UT and then sine of angle T. And if you observe carefully, these angles, the signs will cancel because the angles are equal. And even these will cancel. That leaves us with this. We end up having our PQ times our QR divided by our ST times our UT. So what does this mean? So what this means is what we have is all equal. So PQ times PR and then divided by our ST times SU. That is the same as our PR times our RQ divided by SU times UT, which is the same as PQ, times QR and then divided by ST times UT. Okay, this is what we have. So if you observe carefully, we can now easily find our final answer or conclude this. If you observe and you look at this portion here, look at this one, you will see that it will work out exactly as we need it to, because there's terms that are going to cancel. So if you look carefully, this UT and this UT will cancel. And if you observe carefully, we have RQ and RQ, those will cancel. And then that leaves us with what we need, essentially. Okay. So those will cancel like that. So let's maybe not cancel them here. So that will happen. Then after they are done cancelling, you will see that we'll end up having, you'll have your PR on one side divided by your SU, and this will be your PQ divided by ST, which is exactly what we are required to prove. And that should make you to be very happy. So this here becomes our answer. Okay, I hope that you do understand. With this out of the way, let's go and have a look at the next question. So next, let's have a look at question 3.2. It reads, in the diagram below, triangle VRK has P on VR and T on VK, such that PT, which is this, it is parallel to RK. We are told that VT is 4 units, and we are told that PR, where is PR? PR is 9, and then we are told VP is 2x minus 10. Then we are told to calculate the value of x. So this here should be very easy, because we can put these sides proportionally and just solve for x. So what do I mean by that? 3.3. What I mean is that we can do VT. We can do VT divided by TK, and this should be equal to VP divided by PR. Okay, and the reason for this is our proportionality theorem. So let's go ahead and put in what is given for this problem. So VT is given as 2x minus 10. Remember, what we are trying to do is to solve for x. TK is 9, and this will be equal to VT. That is 4. Well, what did I do now? So VT divided by TK. Okay, now I'm flipping them. So maybe let me write them that. So if you look carefully, VT becomes 4 divided by TK, that becomes 6, equals our VP, that is 2x minus 10 divided by 9. And what we need to do is to solve for x, remember that. So we'll do cross product. Let's make this. So we'll just do cross product, we'll multiply these, and then also multiply these, like that. So what we are going to have is we are going to have 4 times 9 equals 6 times 2x minus 10. Okay, there's a couple of ways we can solve this problem, but we can introduce the 6. So 4 times 9, 4 times 2, that is 18. 18 times 2, that is 36. So we have 36 equals 6 times 2, that is 12x, and then minus 60. So we'll transpose and have 36 plus 60 equals 12x, and this will end up being 96. So we can go ahead and do our division. So we have 12x equals 96. Remember, our aim here is to solve for x. So we need to divide by 12 and divide by 12. And when you do 96 divided by 12, you should be getting your x value, and you'll see that the x value which we get is 8. Okay, and that is what they were looking for. Done with this problem. This here becomes our solution. And I hope that you do understand this and it makes sense. Okay, so let's go ahead and have a look at the next problem, which is 3.3. So let's have a look at question 3.3, where we are told that O is the center of the circle CAKB, and AK is produced, or AK produced, intersects circle AOBT at T, and we are given one of the angles to be X. Okay, and then we are required to prove that angle T will be, if you observe carefully, 180 degrees minus 2x. Now, there's a couple of things that we need to note. So if you observe carefully, you will see that if we look at BTO, like that one, that is a cyclic quad. Okay, so let's go ahead and cook. So if you look at 3.3.1, you will see that our, let's call it TBOA, that is a cyclic quad. Why is it a cyclic quad? It is because all the edges or the vertices, they lie on the circumference. Okay, so we're looking for angle T. So when we look at angle T, we can't directly relate it to X, but we know that angle O is related to angle X. And the question we need to ask ourselves is, how is angle O related to angle X, which is essentially angle C? How is it related to angle C, which is equal to angle X? And if you look carefully, angle O here would be the angle at the center, and angle C is the angle at the circumference. So that angle there, angle OB, it is 2 times angle C. So angle at the center is twice the angle at the circumference. So that becomes our reason, and it's very important that we do put it there. So which means our angle AO will simply be 2x, because angle C is x. Okay, and then now what we need to ask ourselves is, now that we have angle O in terms of angle X, we need to ask ourselves, how is angle T and O related? Now, if we think of the answer to this question, which is how is angle T related to angle O, if you think carefully, they are opposite angles of a cyclic quad. That is how they are related. And what does it mean? What it means is that angle T plus angle O, this should be equal to 180 degrees. It is opposite angles of a cyclic quad. They are supplementary. So we know that angle O is 2x, so which means we have angle T plus 2x equals 180 degrees. And therefore, when you transpose, you will see that angle T is the same as 180 minus 2x. And this here is what your teacher is looking for. So with that done, let's have a look at the next question, which is 3.3.2. So we are required to prove that AC, let's see, where is AC? So that is AC, that it's parallel to KB. Okay. For these to be parallel, there's a couple of things that would need to be true. So the first, or one of the things that would need to be true, is that this angle would need to be equal to that angle. But that should be, let me double check, AC and KB. What would also need to be true for these to be parallel is if this angle is equal to that angle. Okay? Or we have co-interior angles. There's a lot of ways we can go about this problem. But the idea is to think in reverse. Okay? Think about what would be true if these were parallel. So let's go ahead and solve this problem. So the approach we are going to take is we are going to try and show that this angle and this one, they are equal. Okay? So we are going to try and prove that our angle C is equal to P4, which is equal to X. And once we've shown that, we are going to conclude that these are corresponding. These angles correspond, and therefore the lines are indeed parallel. Now, if you observe carefully, we've done some work already. So this entire angle, angle T, is 180 minus 2x. And we have x, meaning we can find the other angle that is missing here, angle A as a whole. Okay. Now, if you look carefully, the triangle, we're looking at triangle CTA. So if you look carefully, angle A plus angle C plus angle T, that should be 180 degrees, and that is just sum of angles in a triangle. Okay, looking for angle A, so we'll have angle A plus angle C, we have x, angle T is 180 degrees minus 2x equals 180 degrees. Let's create some space a bit. Now, if you look carefully, we can transpose and get angle A to be 180 degrees minus 180 degrees. The minus 2x becomes positive x, the minus x becomes minus. Okay? Then if you observe carefully, you'll see these 180s cancelling, and then we therefore are left with angle A being x. Now, if you observe carefully, angle A is equal to x. But then, how is angle A related to B4? Well, remember that, let's make some space. I need you to remember that if you look at CBKT, that is a cyclic quad. So what does it mean, it being a cyclic quad? It means that angle B4 will be equal to angle A, which is equal to angle X, and the reason is going to be the exterior angle of a cyclic quad. So there we go. We now have our angle B4 being equal to X, and we also know that C is equal to X. So because these are equal, we can therefore conclude that the lines are parallel, because we've now shown that this is X, and this could only be true if these were corresponding. So it means we can conclude and say, therefore, our AC is parallel to KB, and the reason we are going to give corresponding angles. Okay, that is what we are going to give, and we are done with that question. Let's go and have a look at the next one. Let's copy that statement, put it here, and if you look carefully, we are required to prove this here. So let's quickly highlight these triangles. So look at triangle BKT. So where is that? BKT. It's that small triangle. And we are proving it's similar to CTA. Okay. So that is CTA. Right. So this should be very simple for us to do. So let's go ahead. 3.3.3. So we are trying to show that we're looking at triangle BKT and triangle CAT. So when we look at BKT, you will see that we have angle T. So angle T is equal to angle T, and this is a common angle. Okay, that is just a common angle. So let's create some. So we are done with that, but also we know what we have proven already. So we know that angle C or angle B4 is equal to angle C, which is equal to X. And this has been proven previously. So it has been proven previously, which was the previous question, okay? And then now, once you have two angles in a triangle equal, the third one becomes equal by default. What does that mean? It means that angle A, it means that our angle A, sorry, we're looking at the smaller triangle. So that means our angle K1 rather will therefore be equal to angle A, okay? Because those are the only angles that are left, okay? And this we can call it third angle, okay? That becomes the third angle. And what you should observe about these triangles, angle A is also equal to X. So you have two angles that are equal to X. What does that mean? It means that the two triangles are isosceles triangles. But let's put up the statement. Therefore, BKT is similar to triangle CAT. The reason is angle, angle, angle. But what we've noted again is that the two triangles are isosceles triangles. So let's have a look at the next question, which is 3.3.4. So we're required to determine AC over our KB, okay, if we are given that to be the case. So let's quickly figure out what is happening here. So I'm going to draw this triangle, and we have the other one inside. And remember, let's maybe just label it and we'll chat. So if you observe carefully, we'll have a T here, and I'll put in a B here, a K here, a C here, and an A here. These are parallel, okay? And we are given a ratio of AK over KT, okay? So we're given that our AK ratio to KT, that will be 5/2. What does this mean for us? Well, what it means is we are going to have 5x here, and then we are going to have 2x here, okay? And remember, we have angles that are equal. So this is all proportional, okay? Let's put in this So this angle here and that angle, they are equal, and yeah, this angle here and that angle there, they are equal. So what you should note is that the bigger than the total side here, or this total length, will therefore be equal to 7x. Very important for us to note, because it then determines the ratio that we are going to use. Then what they want now is AC divided by KB. Okay. If you observe carefully, that is essentially the smaller triangle divided by the bigger one. Okay. So if we go ahead and put these in proportion according to these triangles, so we said AC, which is the bigger one. So if you observe carefully, AC divided by KB, that will be the same as if we go to the bigger triangle, we look at this entire side opposite to the purple angle, you will see that it will be 7x. Maybe not, let's not write that. It will be TA divided by, you go to the smaller side, smaller triangle, it is TK. Then you move to the orange angle, you will see that you have TC divided by, you go to the smaller one, you will have TB. Okay, and then this problem becomes very easy. Yeah, let's just create more space. Yeah, this problem becomes very easy because we already have worked this out a bit and we found the ratios. So if you look carefully, your AC divided by your KB will be our TA. TA will be 7x divided by our TK, that is 2x, which becomes 7 over 2. So what does this mean? It means that our answer, let's create some space, not include that. So this means our answer is this one. It is 7 over 2. So our AC divided by our KB, that will be 7 divided by 2. So that brings us to the end of the questions, and these were the ones which were focused on Euclidean geometry. So this then completes our part 1, and part 2 will focus on the other question. So this one here is the end, and this, remember, is part 1. So make sure that you go and you look for part 2 of this lesson, where we continue with the rest of the questions. So the rest of the questions look as follows. So you'll have that question, and then you'll have your analytical geometry, and then you have your graph sketching and a bit of some calculus there. Okay, that is gonna be in part 2. This here was part 1, and I hope you understood all these questions and the proofs that you needed to understand in order for you to get your marks here. Cheers, enjoy, please share, like and subscribe. Cheers guys.